Welcome back to the deep dive.
Good to be back.
It is Friday, February 6, 2026, and honestly, I am tired. I am so tired.
It's the 2026 fatigue. It's a
Yeah.
real medical diagnosis now, isn't it? I think I read that somewhere.
It might as well be. I feel like this week alone we've had, what, 3 new model releases?
At least.
The grid is flickering again in Texas, and my inbox is just a wall of AI-generated summaries of other AI-generated meetings.
That's a lot.
It is. But usually on this show, when we talk about the stuff, the chips, the software, the agent wars, we talk about it as something happening out there.
External tools, like it's separate from us?
Exactly, like a weather system we're just watching through a window. But the stack of research you brought in today, I read through this last night, and it legitimately kept me awake.
Oh, yeah.
Because it argues we're looking in completely the wrong direction. The AI revolution isn't just about the machines we use.
No.
It's about how the logic of those machines has quietly, almost invisibly, overwritten the operating system of being a human being.
It's a really heavy premise. The core argument from these articles is essentially the people who did machine learning eventually turned people into learning machines.
Which sounds like a clever little tagline, but when you actually dig into the math behind it, it is terrifying.
It really is. The source posits that if you want to understand why everyone is so anxious, why we all feel constantly behind, why modern culture feels so, I don't know,
Flattened.
flattened, exactly. You can't look at sociology or politics anymore. You have to look at the code.
And specifically, 5 concepts from machine learning. Loss functions, backpropagation, gradient descent, overfitting, and the Red Queen.
And we should probably be clear here. We aren't going to give you a coding lesson.
No, God, no. We're going to explain why your life feels the way it does. Because apparently we are all just neural nets trying to minimize our error rates now.
Right.
And really struggling to do it. The source makes this great point that biological evolution takes millions of years.
But the social evolution that's driven by these algorithms is updating every few weeks. We're just running way too hot.
Okay, so let's unpack this. Concept number 1 is the loss function. Now, I know enough about tech to know this is how an AI knows if it's doing a good job.
Right. At its simplest level, the loss function is a math equation. It's the absolute value of the standard answer minus your performance.
Okay.
It's just a way to calculate the gap between perfection and where you are.
And the machine's whole goal is to make that number 0.
Zero loss.
Right.
Total alignment with the standard. But here is where the source gets really dark. It compares the loss function to the Greek myth of Procrustes. You remember him?
Vaguely. He was the guy with the bed, right?
The iron hammer, yeah. He was a rogue smith who had a house by the side of the road, and he'd invite travelers in to sleep on his special iron bed.
Okay, sounds ominous.
But there was a rule. You had to fit the bed perfectly.
And if you were too short?
He'd strap you to a rack and just stretch your joints
Oh my God.
until you snapped into the right length.
That is horrific. And if you were too tall?
He'd take out his axe and just chop off whatever parts of you were hanging over the edge.
Feet, legs?
Didn't matter. The bed was the standard. The human was the variable.
Okay, that's a vivid image. But how is that different from, say, just having a strict boss? Or societal expectations? We've always had standards.
We have, but the argument here is about dimensionality. Think of a human being like a cube.
Yeah.
We're three-dimensional, right?
Yeah.
We have depth.
Sure.
You might be a parent, a daydreamer, a mediocre cook, a great friend.
I am definitely all of those things, especially the mediocre cook part.
Right. But the loss function, the algorithm that runs our economy, it's like a bright light shining on that cube. All it can see is the shadow it casts on the floor.
And the shadow is 2-dimensional. It's a flat square.
The algorithm only cares about the shadow. It flattens you.
I see.
The source uses the delivery rider example, which is the classic case. But let's apply this to a white-collar job in 2026. Say you're a manager. You spend 2 hours comforting a team member who's completely burnt out. You just did something incredibly human and high-dimensional. You exercised empathy.
But the algorithm, the corporate tracking software, it can't see empathy.
Not at all. It just looks at the shadow, and the shadow says, time spent on deliverables, 0.
Email sent, 0.
Your loss just went way up. You are failing the metric. So to minimize that loss, you stop comforting the employee. You chop off that part of yourself, the empathy part, because it doesn't fit the Procrustean bed of efficiency.
Wow. This actually hits really hard. I catch myself doing this. I'll ignore a text from a friend because I'm trying to hit a deadline, and I tell myself I'm being productive,
Right.
but really I'm just minimizing the error rate for my boss.
And the source argues that for society as a whole, that bed is wealth. That's the universal metric. If you are doing something that doesn't minimize the gap between you and rich, the system just views it as noise,
It views your hobbies, your weird thoughts, your art,
as errors to be corrected.
which is a perfect segue to the second concept. Because if the loss function is the measuring stick, then backpropagation is the whip.
The correction mechanism, yes, exactly.
Explain this one, because in neural nets, this is actually how the machine learns, isn't it?
It is backwards propagation of errors. So imagine a neural network. It tries to identify a picture. It sees a cat, but it guesses dog.
Wrong.
Wrong, high loss. The system knows it messed up, so it needs to fix it.
How does it do that?
It goes backward. It traces the signal all the way back through the network, and it looks at every single neuron that contributed to that wrong guess,
Okay.
and it punishes them. It lowers their weight. It effectively says, you fired when you shouldn't have. You are unhelpful. We're turning you down.
So it silences the parts that got it wrong.
It optimizes the path. But now apply this to social behavior. The source argues that we are constantly being backpropagated by social media and the economy.
You mean like getting ratioed on Twitter?
Yeah.
Or I guess X, or whatever we call the zombie version of it now.
Whatever it is this week, that's the most direct example. You post a thought. Maybe it's a nuanced, complex thought, a high-dimensional thought.
Right.
And it gets zero engagement. Or worse, people get angry.
That's high loss.
Exactly. So what happens? Your brain performs backpropagation. You feel that little sting of shame or irrelevance, and you subconsciously adjust your internal weights. You tell yourself, okay, don't say that again. Don't think that way again.
You prune yourself.
You prune the parts of your personality that don't generate signal likes, money, approval. And the really terrifying part the source mentions is the speed and the ruthlessness of it.
Right. In the old days, if you were a bit weird, maybe the village gossip would talk. But it was slow.
So slow. Now, if you post something wrong, the feedback is instant and global.
And it's not just about posting, it's about survival.
Totally. If your skills don't match what the market wants, you get laid off. That is economic backpropagation. The market is literally saying, your weights are wrong, adjust or starve.
I feel like this explains why so much art and content feels the same lately.
Yeah.
Everyone is terrified of that error message, so we all just converge on the same safe, algorithm-approved style.
We are optimizing for the algorithm, not for truth. We are all becoming smooth.
Okay, so we're being stretched on the bed and we're being pruned by backprop. But we still have to move forward, right? We have to build careers. And this is where the third concept comes in. And honestly, this one explains every bad career decision I've ever made.
Gradient descent.
The dark mountain.
That's the visual the source uses, yeah. Imagine you are dropped onto a massive, rugged mountain range at night. It's pitch black. You can't see the peak, you can't see the valley.
But my goal is to get to the bottom. I need to get to zero loss.
Right, so what's your strategy? You can't plan a route. All you can do is feel the ground right around your feet.
Okay.
You find the steepest step downwards right now, and you take it.
That sounds logical.
It is logical, in a way, but in computer science, this is known as a greedy algorithm.
Greedy why?
Because it wants the reward now. It prioritizes the immediate drop in loss.
Over the long-term destination.
Exactly. It's like the marshmallow test, and the algorithm fails it every single time.
Oh, man. This is totally the job hop trap.
It's the perfect example. Think about it. You're in a job, you're learning things, the pay is okay. Then a recruiter pings you, hey, come work for this crypto AI sludge startup. We'll double your salary.
That is a very steep step down the mountain, a huge reduction in financial loss.
So the greedy algorithm in your brain just says, take it, go. You don't ask, is this company a scam? Or will I hate my life in 6 months?
Nope. You just take the step. I literally did this in 2024. I took a job just for the signing bonus. I didn't look at the culture, the product, anything, just the number.
And what happened?
6 months later, the whole division folded, and I was back on the market with a weird gap in my resume.
You got stuck in a local optima. A local optima. Imagine that on this dark mountain, there's a little pothole halfway down. If you just keep taking the steepest step, you'll end up at the bottom of that pothole.
Okay.
You feel safe, you're at a bottom, but you aren't at the true bottom of the mountain. You're just stuck in a hole at 10,000 feet.
And to get out of that hole.
To get out, you'd have to climb up. You'd have to increase your loss temporarily.
Take a pay cut, maybe, or go back to school, look like a failure for a little while.
And the greedy algorithm hates that. It forbids it.
So we get trapped in these dead-end careers because we're too afraid to walk uphill for a bit.
Precisely. And in 2026, the terrain of that mountain is shaking constantly, which brings us to the learning rate and something called gradient explosion.
The source got really intense here. It started talking about mental breakdowns.
Well, just think about the timeline. ChatGPT was late 2022, then GPT-4, then Sora, then the agents. Now we have OpenClaw. The learning rate is the size of the step you have to take just to keep up.
If the steps are small, you can manage.
But the steps aren't small anymore. To stay relevant in 2026, you basically have to relearn your entire workflow every 6 months. That is a massive learning rate.
Okay.
And in AI, if the learning rate is too high, the model doesn't learn, it crashes. It just bounces around chaotically. That's called gradient explosion.
That's the burnout. That's the 2026 fatigue we talked about at the start.
Yes.
Our biological hardware literally cannot process the update patch fast enough.
We're trying to run software designed for silicon on a wet biological brain that evolved to, hunt gazelles. The gradients are exploding all around us.
Which makes the next concept even more tragic, because while we're frantically trying to keep up, we might be learning the absolute wrong things. Concept number 4, overfitting.
The expert's tragedy.
This one scared me the most, because I pride myself on being an expert. I like knowing how things work, you know?
Of course. But in AI, overfitting is when a model studies the training data too hard. It starts to memorize the noise instead of seeing the pattern.
Like a student who memorizes the answers to the practice test but doesn't actually understand the subject.
That's the perfect analogy.
Yeah.
Say you train an AI to recognize cats, but in all your training photos, the cats just happen to be gray.
Okay.
The AI overfits. It decides the rule is gray equal cat. It gets a 100% score on the training data. It feels like a genius.
But then you show it a ginger cat in the real world.
And it says, I don't know, is that a toaster? It fails completely. It optimized for a specific past environment that no longer exists.
The source compares this to the tool specialist, the person who spent 10,000 hours mastering one specific interface.
Oh yeah, think about the Photoshop wizard of 2015. They knew every shortcut, every weird filter. They knew how to manually mask hair pixel by pixel.
They built their entire identity and self-worth around how difficult that tool was.
They were overfitted to Adobe Photoshop CS6.
And then generative fill happens.
And suddenly the test set changes. The real world doesn't care about your manual masking skills anymore. It cares if you can prompt an AI to do it in 5 seconds.
And the expert crashes. Their specific mastery is now just useless noise.
Exactly.
There was a quote in the text here that was just, it was brutal. A play on an old Chinese proverb, "I've eaten more salt than you've eaten rice."
Right, the classic, I have more experience than you.
Yeah, but the source flips it. It says, against an opponent that eats electricity, eating salt doesn't matter.
Oof. Yeah. That is the horror of overfitting in 2026.
Because experienced salt is usually a good thing. But if the rules of the game change overnight, that experience can actually be a liability.
It makes you rigid.
Yeah.
You keep trying to use the old methods because you're so good at them, while some novice just asks the AI and completely blows past you.
So we're running faster and faster, trying not to overfit, trying to find the bottom of this dark mountain.
Yeah.
And that leads to the final concept, the one that guarantees we never ever get to rest.
The Red Queen effect.
From Alice through the Looking Glass.
Yeah.
Now here, you see, it takes all the running you can do to keep in the same place.
It's the mechanism of the infinite treadmill. In biology, it's the classic cheetah and the antelope. If the cheetah evolves to run 60 miles per hour, the antelope has to evolve to run 61.
But the outcome is the same. The cheetah doesn't actually catch more food. It just works way harder to get the same dinner.
And now look at the modern office. We were promised that AI would give us the 3-day work week. Remember that?
I do remember that. I am currently not at the beach.
Because of the Red Queen. If you use an AI agent to do your work in half the time, you don't go home early. Your boss and the market, they just adjust the expectation.
Oh, you can do that in 4 hours. Great. Now do double the volume.
The passing grade was raised.
Yes.
We simply moved the entire baseline. So now, to be a functional employee in 2026, you have to use these tools just to survive.
You're not getting ahead. You're just preventing yourself from falling behind.
It's an infinite game. There's no finish line. There's no point where you can say, okay, I'm efficient enough now.
No, because the loss function always demands 0. The gradient always demands you take another step down. Okay, stop. We have to stop. Because if we end the deep dive here, I'm going to go curl up in a ball and disconnect my router forever. This is incredibly bleak.
It is.
We are trapped in a math equation that fundamentally hates us.
It is bleak. But the source doesn't actually leave us there. It brings up Geoffrey Hinton, one of the godfathers of AI.
The guy who left Google to warn everyone about this stuff.
That's him. He expressed this profound regret that we've basically trapped humanity inside these algorithms. But the source suggests there is a way out, a kind of hack.
Please tell me it's not buy more Bitcoin.
No, it's actually about defying the math itself. Remember gradient descent, how it gets stuck in those potholes because it's so greedy.
Yeah, it only takes the step down. It absolutely refuses to go up.
So the only way to find the true answer, the global optimum, is to stop being greedy. You have to be willing to increase your loss.
You have to be willing to lose.
Temporarily.
Yeah.
You have to be willing to look like a failure. You have to be willing to be inefficient. The source calls it mutation-style evolution. In computer science, when an algorithm gets stuck, sometimes you just inject random noise. You shake the box. You force it to take a bad step just to see where it leads.
So, in human terms, what does that mean? Stepping off the treadmill.
It means taking the pay cut to learn some weird skill that no one values yet. It means spending an afternoon doing something that has zero ROI, like painting badly or just staring at a wall.
It means ignoring the backpropagation from social media, posting the thing that gets no likes just because you think it's true.
Exactly. The core argument is that in a world completely optimized for machines, inefficiency is not a bug, it's a feature. It is our last line of defense.
Why?
Because the machine cannot choose to be inefficient.
Yeah.
It cannot choose to violate its loss function.
But we can.
We can.
We can choose to be messy. We can choose to walk uphill.
And that might be the only way to stay human in 2026, to actually be the glitch in the system.
That is actually kind of hopeful.
Yeah.
A weird punk rock sort of way.
I think so. The system wants you to be a smooth, optimized, efficient vector.
And the hack is, don't let it smooth you out.
Keep your jagged edges.
I like that. Be jagged. Well, that is a lot to process. I think I'm going to go do something incredibly unproductive now. Maybe I'll go read a physical book and not even highlight anything.
Radical.
Thanks for listening to The Deep Dive. If this episode raised your anxiety, just remember, that's just your gradients exploding. Take a breath, walk uphill for a bit. We'll see you next time.